everyone, I am Revati M and my batchmates are Aparna, Aishwarya and Karunya. Our project is guided by Mr. Ruben Thomas, ME, Assistant Professor at Electronic and Communication Department. Our project title is a non-linear transformation based SBox for improving security in AES cryptographic primitives for EMR applications. Our abstract is to investigate a novel AES cryptographic realized on FPGAs which poses a serious threat to real-world application. We demonstrate how a targeted bitstream modification can seriously weaken cryptographic algorithms, which we show with the examples of AES. The attack is performed by modifying the FPGA bitstream that configs the hardware elements during initialization. Recently, it has been shown that cloning of FPGA designs is feasible even if the bit streams is encrypted. We target the SBoxes of large chippers that can implemented in lookup tables or stored as pre-computed set of values in the memory of the FPGA. We demonstrate that it is possible to detect and apply meaningful changes to SBox cryptographic elements inside an unknown proprietary and undocumented bitstream. Furthermore, we show how an AES chipper level is increased with SBox model. Objective: to increase the throughput range and security of AES crypto system with LUT-based implementation of SBox by multi-level composite field computation-based SBox solution approach. Second, to optimize critical path delay by dividing combinational logic inside the elementary operations for deep pipelining. Third, to overcome the key management issues using biometric driven key extraction process. The existing work is a novel method for generation of strong substitution boxes based on coset graphs and symmetric groups. It takes place on the IEEE Digital Journal paper. In the existing work, multi-level SBox units are used for maximizing the confusion matrix during random attacks. Combination circuit is used for SBox implementation which increase security. SBox is modified as one-way mapping function. Linear transformation is converted into non-linear functions. And the drawbacks of existing system is biometric physical identities are directly assessed for authenticity activations in biometric systems. Crypto system key management is a major issue which will be the major cause in hacking. And our proposed system is to design hybrid transformation methods to avoid the possibilities of any key leakages and any vulnerabilities in AES crypto system, to integrate robust biometric systems with unique key generation module for solving key management issues, to improve the overall security with outer layer transformation using multi-level crypto system, implement proposed image metric key driven AES core for EMR applications. And the advantages of our proposed system is data rate is very high, able to process high level chipper in any real-time data, outer level security is high. And bio encryption. In this block diagram, we are going to see our overall process. Here, input text is the input passwords or any biometric signals informations we are going to given, and ASCII conversion. In ASCII conversion, the numbers and alphabets are mixed together and which is fed into the key generation. In the key generation, it is also mixed with the biometric informations. From the biometric informations and key generation, it is led into the SBox permutations where the mixed columns, shift key, substitution bytes, the process for securing the password will be done. It is given to the cyclic addition and based on the cyclic additions and key generation output, it is given as the chipper out. From the chipper out, our password is secured, and since the AES is the advanced encryption method, there are some attacks in AES. The attacks are in AES are side channel attacks and differential cryptanalysis. The side channel attacks are the attacks based on studying and measuring the actual implementation of the code, while differential cryptanalysis is the difference in the output based on the input given. In differential cryptanalysis, the hackers used that scanning technique to carry out this attack. It is by calculating the input out on the output difference. If we are giving a number as 1, if the output is 5 and the number as 2, if it is attained, they will analyze it as a multiple of 5. They can easily identify the password and get the password, thread the password by recognizing as it will be a multiple by 5 algorithm. The algorithm we are going to use in the proposed system is in two types: initializing transformation process, replacing S boxes to the identity functions, changing linear S box into a non-linear function to overcome the highly vulnerable cryptanalytical attacks. And next, replacing S boxes to the random function. Bit streams can be altered to always output to unpredicted results regardless of the input value. If we are given the value as 1, for which the output is -1, while for 2, if it is the output will be the -28 or some other anything, it will be a more confusing one for the hackers. Simulated chipper output. As we seen in the block diagram above, the chipper output is the confusing one. If we are not a hacker and we are the user provided by the service providers, we will get the chipper output as 00 for our passwords. If we are the hackers and trying to track the algorithm, we will not get the 0 as the output. And it is the area report, it is the flow summary. It is total register you are using is 40, total pins is 80 by 347, and virtual pins, it is the device or EP331-6F 484C6, and the family Cyclone 3, top level entry name S-box. It is the Fmax report. These channel reports Fmax for every clock in the design regardless of the user specified clock periods. Fmax is only computed for paths where the source and destination registers or ports are driven by the same clock. Paths of different clocks including generated clocks are ignored here. For paths between a clock and its inversion, Fmax is computed as if the rising and falling edges are scaled along with Fmax such that the duty cycle is maintained. This is the linear memory LUT S box. Here it is a linear transformation based S box hardware model, and this is the confused S box, that is non-linear transformation based S box in the hardware view. Logical depth analysis of various S box types. The Xbox in LUT based and dynamic non-linear based. The area is reduced from 216 to 80 and the Fmax frequency is increased from 228 to 509. This is the biometric digital image. Based on our biometric information, it is converted into bit streams and the password is selected randomly as any of the 6 or 8 digits based on our requirements. These are our references. Based on this reference, we came to finish our project. successfully with full involvement. We thank our guide and staffs who helped us in this project to complete this project a successful one. Thank you.